Hey everybody, Mr. Covey here, and today we're going to talk about U substitution. So this is a technique for taking antiderivatives that we haven't talked about yet. So first off, the reason we need it is for if we wanted to take the antiderivative of something like that. You'll notice that this whole thing is squared. So if we wanted to take the antiderivative, we'd essentially have to undo chain rule. We don't know how to do that yet. Luckily, U substitution does that. So why do we need it? We really need it to undo chain rule. Because if you took the derivative of this, you'd have to bring down the 2. You guys are good at this. And then times 3 for the chain rule. So since the derivative involves chain rule, the antiderivative, we need to undo that chain rule. In order to undo the chain rule, we need this new technique. Okay, so that's what we're going to talk about today. These are the steps we're going to follow, and I think it's just easiest if we go through an example and I'll reference back to these steps. So go ahead, flip to the next page. We are going to do this problem. So we're trying to take the antiderivative of this. Here there's an inside part. So if you did the derivative, you'd have to use chain rule. So we're going to have to use backwards chain rule, which is this U substitution technique. So here's what you do. First, that inside part you call U. So in this case, U is going to be x cubed plus 2. Okay? That's step 1 if you look back at our steps. Step 2, we're going to take the derivative of that. So we're going to get 3x squared. But think back to when we did the derivative with related rates problem. Since we have a u over here, we're going to say the derivative of u is 1 du, because we did the derivative of a u term. And on the right here, when we do the derivative of x cubed, we get 3x squared dx, because we took the derivative of an x term. Okay? That's step 2. Step 3 is to solve this new equation for dx. So we want to get this dx by itself. We're going to divide both sides by 3x squared. So we get du divided by 3x squared equals dx. Fourth step is to sub this in for dx and sub this, sub u in for this. So we're still going to have our integral of 6x squared. Instead of calling it the square root of x cubed plus 2, I'm going to call it the square root of u. And instead of writing dx, I'm going to write du divided by 3x squared. Okay? Now we need to simplify this a little bit. So I'm going to bring it over. I have a 6x squared square root of u and a du on top, and I have a 3x squared on bottom. Simplify this. Those are going to cancel out, but they're going to leave a 2 up top. So I'm at 2 square root of u du. And now I'm in a place where I've gotten rid of all my x's, I only have u's, and I can do the antiderivative of this. So I'm going to do that. I got rewrite it as 2u to the 1/2. Antiderivative will be u to the 3/2. And that exponent out front, coefficient, will be 4/3. So I actually do my antiderivative here. And then now I just sub back in what I called u originally. So remember I called u x cubed plus 2. So now my antiderivative is 4/3 x cubed plus 2 to the 3/2 plus c. So there is my final answer. Big picture here is you choose a u, you sub it into your integral, and you do some simplification until you get to a point where you can actually do the antiderivative in terms of u. You do that antiderivative, you sub back in the x terms, and you have the antiderivative in terms of x. Okay? This is a tricky process. We are going to practice it a lot. So let's just go ahead and dive into another example. And I'll give you some advice about the steps as we go along too. So your first step is to decide what u is going to be. If you go back to your steps here, a couple pieces of advice. Your u usually wants to be the inside part. So if you have like a function with an inside part, that's a good choice for the u. Okay, and we'll do some more practice. There's some other situations too we will talk about. But in this case, there's this part that's inside the square. So I'm going to choose my u as x squared plus 2x minus 3. Next, I'm going to take the derivative. Again, think back to related rates. Derivative of u is 1, but I'm going to add a du. Derivative of x squared plus 2x minus 3 is 2x plus 2. Add a dx. Should really put parentheses here. That's important. Next, I'm going to solve this for dx by dividing du by 2x plus 2. And now I'm going to sub everything back into my original. So you need to be careful at this part. I have the integral of u, because this is what I called my u, of u squared. That x plus 1 stays there. And instead of writing dx, I'm going to write du divided by 2x plus 2. Let me push that all together. This is a crucial step here. If we're going to take the antiderivative in terms of u, all of our x's have to cancel. So if you don't get your x's to cancel here, you chose the wrong u. Luckily, in this case, they do cancel. If you want to think about why, you could rewrite 2x plus 2 as 2 times x plus 1 with parentheses. We get those to cancel. And what we are left with is, the antiderivative of u squared over over 2 du, which we can do the antiderivative of. We've gotten rid of all of our x's, and it's something we can actually do the antiderivative of. So let's do that. Antiderivative of that is going to be u cubed, and I'm going to want a 1/6 out front, plus c. And then last step is just to sub back in whatever I made u, so that my answer is in terms of x. So I'm not going to say 1/6 u cubed plus c. I'm going to say 1/6 x squared plus 2x minus 3. And that's my final answer. Again, we're taking the antiderivative. We're taking the indefinite integral. So you could always check this answer by taking the derivative and seeing that you end up with what you started with up here. Might be factored a little bit different, but that is true. Okay? One more example I want to run through here. Okay, so first we're going to choose our u. Again, choose the inside part. I'm going to choose that part inside the square root. So I'm going to choose 1 minus r cubed as my u. I'm going to differentiate both sides. Add a du. Add a dr, because I took the derivative of an r term. I'm going to solve this for dx, or in this case, dr. Oops. I'm going to sub it all back into my original, and hopefully I get some stuff to cancel. Instead of writing dr, I'm going to write du divided by negative 3r squared. Instead of writing the square root of 1 minus r cubed, square root of u. Again, here's where the simplification comes into play. These two are going to cancel, but I'm going to be left with a negative 3 on top. So I'm really have negative 3 over the square root of u du. I picked my u right because I got to a point here where I can actually do the antiderivative of this. So all that work before is to get it to look like this so that I can actually do the antiderivative. You'll remember from last chapter that we should rewrite this as a u to the negative 1/2. And now let me just do my indefinite integral. My new power is going to be 1 more, so it's going to be 1/2. My coefficient out front is going to be a negative 6. Don't forget the plus c. Finally, I'm just going to look at what I called u originally. I called it 1 minus r cubed. I'm going to sub it back in so that my antiderivative is negative 6, 1 minus r cubed to the 1/2 plus c. Looking back at our steps, a couple of other pieces of advice. When you differentiate both sides of the u equation, think about it like how we did derivatives when we did related rates, where if you take the derivative of an r term, you add a dr. Take the derivative of an x term, you add a dx. Rearranging it should be not too bad. When you sub back into original integral, really right here there's another little step, and that is to get some stuff to cancel. Because at the end of the day, you just want it in terms of u. So before you can take the antiderivative, we need to have only u's and only a du. So you can't have a u and a dx that doesn't match up like that. Okay. Again, we are going to practice this a lot during class, but I just kind of wanted to get you guys started on this. There is one problem I'd like you to try on your own, and that's this one right here. So if you could try this on your own, come into class and we'll review it to start. I'll get you guys started on the right step here, or the right foot. What should my u be? It's going to be the inside part. So start by deciding that your u is going to be 5x squared minus 4. You guys go from there, bring that into class on Tuesday, and we will discuss it.